Assalamualaikum students. Today we start ex2.4. Here we use suitable substitution. We have a question: y is equal to x plus square root x whole square root. Now we let the base is equal to u. So it becomes y square root u. We differentiate both with respect to x and this with respect to u. When we differentiate with respect to x, the left hand side become du by dx, and right hand side derivative of x is 1 and derivative of x square root is 1 over 2 minus 1. Now the derivative of this question with respect to u, dy over du, and derivative of u, again same formula as we apply on x, 1 over 2 u 1 over 2 minus 1. Now at the end we apply chain rule to find dy by dx. We multiply above these values du by dx and dy by du. Dy by du, its value is 1 over 2 u 1 over 2 minus 1, and its value is 1 plus 1 over 2x minus 1 over 2. Now we put these values and simplify. Here we again put the value of u. Now in this part we let u is equal to a plus x and a minus x. Now y becomes x and a plus x and a minus x replaced by u. Now we differentiate it with respect to x. Now left hand side become du by dx, and on right hand side we apply quotient rule. Here n is a plus x and d is a minus x. We put these values in the formula. So derivative of a is 0 and derivative of x is 1. We differentiate only those values where we have dy by dx. Derivative of a is 0 and derivative of x is 1. Then we multiply these values. It becomes 2a over a minus x whole square. And next question we have there y x square root u. We have three variables y, x and u. We now differentiate with respect to x. Now here two variables on right hand side, x and u, so we apply product rule. Now this is product rule. If we have two values a and b, we differentiate these values, then it becomes d over dx a dot b plus a derivative of b. First we derivative of first function and next we derivative of second function, and between there are plus sign. Now here we differentiate with respect to x. A is x and b is square root u. We put these values. Derivative of x is 1 and derivative of u is 1 over 2 minus 1, and then derivative of base, because we differentiate with respect to x, it becomes du by dx. Now here we put the values of u and du by dx and get the answer. Value of u we let in the question, and du by dx we find here. This is, we put these values and this is the answer. Now in question number 2 we have mixed form, implicit differentiation, 3x plus 4y and plus 7. Now derivative of x is 1, derivative of y is dy by dx, and derivative of 7 is 0. We move 3 to other side and 4 by division, and this is come minus 3 by 4. Again we differentiate this. On x and y we apply product formula. A is x, b is y. This is product formula. And y square we apply 2y 2 minus 1 and then derivative of base dy by dx, and derivative of 2 is 0. Now we apply product rule. Derivative of x is 1, derivative of y is dy by dx. Now in this question we have 2 dy by dx. We common these values and y to the right side and then divide it by x plus 2y. Now in this question we have a question 4x square. We differentiate it by respect to x. Derivative of x square is 2x and power is 2 minus 1. Derivative of x dot y. Here we apply again product rule. Derivative of x and then y plus x and derivative of y. Derivative of y square is 2y, power is 1, and dy by dx base derivative 2g x, derivative of x is 1, 2f y, derivative of y is dy by dx, and derivative of c is 0. Again derivative of x square is 2x, derivative of x and dot y we apply product rule. Derivative of y square is 2y dy by dx. Derivative of x is 1. Derivative of y is dy by dx, and derivative of c is 0. Now we multiply in the bracket and then we arrange the values. Common dy by dx in left hand side and other values to the right hand side, and then divide by this value, and this is the answer. Now in this question we prove y dy by dx plus x is equal to 0. We have value x is equal to 1 minus t square over 1 plus t square. We apply there quotient rule n over d. We put these values in n and d, and here we differentiate with respect to t because we have right hand side with variable t. Derivative of 1 is 0 and derivative of t square is 2t because power moved to the multiply with the variable and we subtract 1 from the power, so it becomes 2t. And also in the next bracket derivative of 1 is 0 and derivative of t square is 2t. We multiply these values and this is the answer of dx over dt. In this question we again apply the quotient rule. Here we have numerator is 2t. We put these values in quotient rule. Derivative of 2t is 2 and derivative of 1 plus t square is derivative of 1 is 0 and derivative of t square is 2t. We multiply these values and this is the answer of dy over dt. Now we apply chain rule. Dy over dx is equal to dy over dt over dx over dt. We put these values and then this is the answer of dy over dx. Now to prove this value is equal to 0, we put three values here: value of y, value of dy by dx, and value of x. and then simplify, and we get the answer is 0. Here we have the same question, but we have only A on the right hand side and B on the. We apply on both these parts quotient rule, and then we apply chain rule. Here we see that the quotient rule, we apply these values. We A take common. Same derivative of 1 is 0, derivative of t square is 2t. Here we common 2b because it is constant, and derivative of these values apply quotient rule. Derivative of t is 1, derivative of 1 is 0, derivative of t square is 2t, and then we apply chain rule, and this is the answer. Now here we have question 1 plus x square whole power n with respect to x square. We let one function is equal to y and other is z. We apply the differentiate. Now first we differentiate with respect to x, power move and multiply with the base, and we subtract 1 from the power, and then derivative of the base. Derivative of the base, derivative of 1 is 0 and x square is 2x. And then other function we have x square dz by dx, its derivative, and derivative of x square is 2x. Again we apply a chain rule, dy by dx and dz by dx. We put these values and get the answer. Now here we have these two values, both are in fractions, and we let one is y and other is equal to z. Again we apply the quotient rule, n over d. Now its derivative is, we put these values in quotient rule. Derivative of ax is a and derivative of b is 0, and then we multiply these values, and in this fraction we again apply quotient rule. Derivative of ax square is 2ax and derivative of b is 0. A number without a variable, its derivative is 0, and x square derivative is 2x, so it becomes 2ax. Again multiply these values, and then we apply the chain rule and put these values and get the answer. Now here some important question. This is the question of question number 1 and fourth part. Here we apply substitution rule. We let base is equal to u, and it becomes yu6, and differentiate with respect to x and differentiate with respect to u and apply chain rule. And this is another important question, question number 2 part. We apply both these equations, product rule. This is the product rule, derivative of a into b plus a dot b derivative. We put these values in product rules. Then derivative of x is 1, derivative of 1 plus y square root is 1 over 2 minus 1, and then derivative of base derivative of 1 is 0, derivative of y is dy by dx. Here again derivative of y is dy by dx, and derivative of 1 plus x is 1 over 2, 1 over 2 minus 1. Its base derivatives 1, 0 and 1. So we arrange these values. Dy dx, we common this value, and other two values move to the right hand side and then divide by the value which multiply here by dy dx. On these questions. Okay student, try to solve these questions. If you have any problem then send it to me. Jazakallah.